new wire. Okay, so we have a situation here where we are having first wire as this. Okay, so let's suppose the length of wire is L. Okay, now the same wire is drawn to so that its length increases 3 times. So now when I talk about the second wire, so the same wire, okay, is like this. So now the distance, the new length of the conductor or this wire is 3L. Okay, here it is given that resistance of the wire is 10 ohms, and here we need to find out the new resistance. Again, in this problem, we have the concept of rho L by A. Okay, so rho will be same for both the wires because we are talking about the same wire. So what about the concept in terms of length and area? Okay, so you can see here the length is increased. Okay, so what can you say about the area, students, or area of cross section? Whenever I'll talk about area of cross section of wire, I mean to say these areas.
Sir, area of cross section will decrease.
Okay, so so likewise, these all are the area of cross section. Okay, now, so just now one of your classmates, he said area will reduce if we increase the length. So can we talk about the volume concept now? Volume associated with the wire.
Volume will remain constant.
Okay. Students, anyone else? What can you say about the volume?
Remain same, sir.
They should be same. Why? Because obviously this is the wire. So I am elongating it to a length that is thrice the original length. But obviously the volume contained by this wire is remaining the same. Why? Because here when length is increasing, we have seen like we always will have the area of cross section will decrease here. Okay. So let's suppose volume, initial volume is V1 and the second wire that is also volume 2 I am writing here. So here I mean to say that volume remains same for both the cases. Okay, so can you tell me volume in terms of area and length? So
Wire.
area into length I am talking about here. Okay, so this corresponds to my volume. That means area of cross section of the initial wire multiplied by the length of the initial wire will be always equal to area of cross section of the elongated wire multiplied by the length of the elongated wire. So in this way we can say that my volume is constant. Okay, so when I talk about A1, so let's take it as A1 itself, or if you want to generalize, let area of cross section is A. So A into length be L. Okay. Now we are interested in this area too. Okay. So this multiplied by new length is 3 into L or 3L, because so sorry for the interruption, students. Okay, so I'll have to again do this. So here we talked about area into length of first wire is equal to area of the second wire multiplied by 3L1. Okay, if this is L1, this should be 3L1. So from this, we can get that area of cross section of the new wire, or the second condition, is nothing but A into L upon 3L. So area is getting reduced by 3 when we talk about the new situation. Here we have the concept of volume to be constant. Okay, now R1 is nothing but rho L1 upon A1, and R2 is nothing but rho L2 by A2. When we'll divide these two equations, we have R1 by R2, rho cancel. So L1 A2 upon L2 A1. So L1 I am taking as L. A2 I have found out that is nothing but A by 3. So A in denominator I have 3 here. L2 is the new length, that is 3L, and A1 I have taken as A itself. So this is my R1 by R2. Okay, so R1 by R2 comes out to be L cancel, A cancel, so it is 1 by 9. Now this value is given as 10 ohms. This I need to calculate. This value I have. So R2 will be 10 into 9, that is R2 equals to 90 ohms. So students who have found out that new resistance is 90 ohms is correct for them. Okay, so we'll just see the answer. Okay, sorry. So you can see here, the length of the wire is made 3 times. Okay, so new length is 3L as per this. The area of cross section must decrease 3 times. Okay, if we increase length 3 times, the area of cross section must decrease 3 times. Okay, so here we are talking about decrement in area by 3 times, because the volume of the wire remains the same in the process. Okay, so the same thing they have tried to assign the values rho L by A. Okay, and we know that the new length is always 3L. Okay, so for this, so we have this as L2 into A1 upon L1 into A2. Okay, new length is 3L, area let's suppose it is A, length is L, and new area is A by 3. So this 3 will go and multiply here. So it is 9 in terms of R2 by R1. So this I know 9R1, 9 into 10, which is given as 90. So this is 90 ohms. Okay, so your answer that the resistance is 90 ohms for the new case.